So now we stepping up to how to look at a standard form. If I look at a standard form, right, how do I know I will have two x-intercept? How do I know I will have one x-intercept? How do I know I will have two imaginary? Well, how do I know I don't have a intercept at all? Which eventually would turn into imaginary numbers, so imaginary zeros. All right, let's go back and look at some stuff that we talked about in the past. So two real numbers, two real zeros, also known as two x-intercept, right? Or I also call it two solutions, right? We also call it, so we call it zero, we call it x-intercept, we call it solution. Is there anything else that I'm forgetting? The famous one, the one that starts with R, roots. All right. So I'm gonna go back to red. All right, great. So if I give you a standard form, right, you're gonna use what we call the discriminant, right? Discriminant, meaning in the quadratic formula, when you have this, right, b plus or minus negative b plus or minus square root of b squared minus 4ac, all of that over 2a. I am talking about right here. That is the discriminant, the b squared. If that number, let's say that number turned into, let's say you're doing your math, right? And that number turned into b square root of 16. If square root of 16 is greater than 0, which is right here, if that is greater than 0, then you have two solutions. That means you don't even have to graph it. You just know it hits twice on the x line. Or let's say it's looking downward. It hit twice downward on the x line. Boom. All right. Next one, how do we know we have one x-intercept or one solution or one root? If that number equals 0. So I'm back here. Instead of having 16, what if I had 0? This number is clearly 0 without even putting in the calculator. I'm just looking at the inside of the square root. If that number is 0, meaning it really equals to 0, right? Don't even plug in the calculator. You're just looking at these numbers. That's 16. This one is 0. If that is 0, that means you have one solution. Meaning if you don't even have to graph it. If it equals 0, then you know it touches the x just once, right? Just once. Right there. Just once. All right. Now, here's the new thing for today, because what I'm telling you is not new, but here I'm about to tell you is the new stuff. If that number is less than 0, meaning that number would have to be a negative, right? Less than 0. If it's a negative, I don't know, a negative 2, maybe, because that's a negative, you would have an I coming out of that, right? Like this. That means you would have what we call imaginary zeros. You have two imaginary zeros. Okay, so bottom line, you're not going to have any x-intercept at all, but you have, if it's like this, opens up over there, no x-intercept, but you have two imaginary numbers. Even if it opens up right here, even downward right here, no zeros. We also call it real. Another word that I should bring here. That's what it says, real. These are real numbers. Like when I say real, I'm talking about all of this, right? So imaginary means no real numbers. No real numbers. But instead, you have nothing but imaginary stuff. Imaginary numbers. All right? And anything else? Like this one right here, you can just plug it in your calculator. If you have it in a vertex form, just plug it in and look at it. Clearly, you can see if it has two solutions, or if it has, if it has two solutions, or if it has one solution, or if there is no solution at all. Let's say you have no solution, which is no real numbers, right? Then if you don't have any solution, guess what you have, my friend? You have an imaginary solution. All right? So same thing here. One thing I want you to remember from these videos is no solution, no solution, or no real solutions equals to imaginary solutions. All right. That's it. No solutions, meaning you actually have imaginary ones. All right. Use this concept that I just said. You just what you learned from me. Go ahead and try to complete the next